Okay, so I'm going to go over some practice problems for colligative properties. So the first 4 questions all are dealing with boiling point. So if you guys remember correctly, an increase in solute concentration leads to an increased boiling point. So what that means is they have to add more temperature in order to get the molecules to leave the liquid phase. This is because the particles are getting in the way, that solute is getting in the way of them leaving and becoming the gas state. So, which of the following solutions would have the highest boiling point? So, what you'll notice in this problem is that they're the same particle. So in this instance, we're just going to focus on the concentration. And we're just going to look to see which one has the highest concentration. So in this case here, we have 0.1, 0.2, and 0.3, so the highest would have to be C. This will give us the highest boiling point. It has the most solute, so the most stuff getting in the way of things leaving into the gas phase. Question 2. Which of the following solutions would have the highest boiling point? Again, we're going to look at the concentration. Oh, looks like they're all the same. So we can ignore that and we're going to solely look at what's going on here. So we've got 3 different particles. So to tell the difference between these, there's a trick that you guys need to know. It's something that was in the notes from earlier that you guys probably watched through. But looking at these 3 types of compounds, we've got to figure out what's going on. The trick is to understand what colligative properties is. So colligative properties is not dependent on the type of compound. It depends on the number of particles. So what we have to do is we have to figure out when these things dissolve in water, how many particles are going to be present. So a key thing that we need to look at here is specifically if it is ionic or covalent. Now, in the notes, I told you that ionic compounds dissolve into ions, and covalent compounds do not. They're going to stay as one particle. So here we have potassium chloride. And if you look at a periodic table, potassium is a metal and chlorine is a nonmetal. So this is ionic. So it is going to break into 2 particles. Okay, 0.2 molar of NaCl. Well, you guys probably remember that salt, NaCl, is an ionic compound. So sodium is a metal. It's on the left side of the periodic table, and chlorine is a nonmetal. So again, this one is going to have 1 and 2 particles. Okay, the last one is calcium chloride. And if we look on the periodic table, we would find that calcium is a metal and chlorine is not a metal. So this is also ionic. And so we're going to have 1, and we have 2 of these. So 1 plus 2 is 3 particles. So if colligative properties depends on the number of particles, the one that has the highest particles, the most solute, the most stuff, is going to increase the boiling point. So we're going to go with C here again. So question 3 gets a little trickier because we have different concentrations and we have different things going on here. So we've got different compounds. So we're going to need to look at the number of particles and we're going to look at the concentration. Now what I do is I typically write these out and then I'll just times them by each other to get my overall solute concentration. So let's first look at the number of particles. For C6H12O6, this is your sugar, your glucose. this one right here is a covalent compound. And how I know is that all three of these, carbon, hydrogen, and oxygen, are nonmetals. So this is covalent, and covalent compounds do not break down in a solution, so it's going to stick together. This is going to stay as one whole molecule. Okay, and the next compound is sodium chloride. Again, from up here we know that this is ionic because there's a metal, and it's going to break down into two. So when it breaks down in a solution, it's going to have two things that break apart from each other. And the last one on here is calcium chloride. Again, we looked at that one up here. It's ionic because calcium's a metal and chlorine's a nonmetal, and it's going to split into 1, 2, 3 compounds because we have 2 chlorines. So in a solution, we'd have calcium, chlorine, and chlorine. So in our solution, we'd have 3 different particles. So you guys would probably say that this one might be our answer, but we got to look at the concentration. So we have a certain concentration. This little m stands for molality, or what I want you guys to think of for now is the number of moles. So we're going to take this number and times it by the number of particles to get our new concentration. So I'm going to take 1 times 0.4, and this will give us 0.4. I'm going to take this one 2 and times it by 3, and we'll get 0.6. And we'll take this one and times it by 0.1, and we'll get 0.3. So the answer here has to be B because it has the most particles and the most concentration. So this is the answer for 3. Let's try another one of those. These have kind of similar concentrations and different particles over here. So we're going to do the same thing. We're going to look at number of particles, and we're going to times them by the concentration. Okay, so again, this is a covalent compound, so it's going to be just 1 particle. I know that because C's and H's and O's are all nonmetals. Again, NaCl is ionic, and it's going to split into 1 and 2. This one right here, calcium chloride, is going to split into Ca and Cl2. So like we did over here, it's going to split into 3 particles. Okay. And the last one is KBr, potassium bromide. So we need to look at a periodic table to find that potassium is an alkali metal. It's in the first group or first family, so this is a metal. And bromide is a halogen. So metal and nonmetal. So this is ionic, and it's going to break into 2 particles. So let's just double check with our concentrations, but we're going to times it here and get our answers. So I just added the concentration that was here. Okay. And if we did the math for that, we'd find 0.3, 0.6, 0.9, and 0.4. So your answer has to be C. So these all have to do with boiling points. So I'm going to flip it over to the back. I have 3 more problems that are talking about freezing points. So let's take a look at these. So freezing point is kind of similar to boiling point, where as we increase the solute concentration, what's going to happen is we're going to actually decrease the freezing point. Okay, so the opposite is kind of happening from our boiling point. Our boiling point is going to go up when we add solute. We need to add more energy to get those molecules to move. But to add concentration to our thing that is freezing, if we add more, it's going to cause it to kind of slow down the process because those particles are getting in the way of it becoming a solid. So those solute particles get in the way, which lowers the freezing point. So let's take a look at this one. Again, like we did on the first one, these are all the same concentration. So we're going to solely focus on the type of compounds these are. So potassium iodide, how many particles would this break into? Well, potassium is a metal, it's an alkali metal, and iodine is a nonmetal, it's a halogen. So these two are going to break into 2. Calcium chloride, now we've done this one, this is a ionic compound because it's got a metal and 2 nonmetals. So this one right here would be 3. C's, H's, O's, H, those are all nonmetals. So this is going to be just 1 particle because it's covalent. They're all nonmetals, which tells me it's not going to split up like ionic compounds. And NaCl we've done is going to have 2 because it's ionic. Okay, now we don't have to times it by our concentration here. We could, but we're not going to because they're all the same, which we'll find which one of these is the highest, which would be B. Okay, the next one, which of the following freezing points, or which of the following solutions would have the lowest freezing point? So we have 0.1 m for potassium iodide, which over here we saw that it had 2. We have NaCl, which we know has 2. And last but not least, C5H12. C's and H's are both nonmetals, so this is going to be 1 particle because it's covalent. Okay, at this point what I'm going to do is I'm going to times them by the concentration that I get from this. So we have 0.1 molar solution of 2 particles, so 0.2 is our new concentration for the particles, and then times this one by 0.2 and we get 0.4. We'll times this one by 0.3 and we'll get 0.3. So your answer is B. Alright, this last one is kind of tricky, so hopefully you guys stayed with me up to this point because this one is where it gets a little tricky because we've got these parentheses in here causing this thing to look crazy. So which of the following would have the lowest freezing point? So our concentrations are different and our particles are different, so we're going to do we're going to look at both. So let's take a look at this one first. Lithium. If we look at the periodic table, lithium is an alkali metal and bromine is a halogen. So this is ionic and it's going to split into 2 particles. Okay. Potassium chloride. Potassium is an alkali metal and chlorine is a nonmetal halogen. So this will split into 2. Okay, I'm going to skip down to this one so I can explain what's going on with this one in just a second. This is phosphorus trichloride, phosphorus trichloride. So this one, phosphorus, if we look on the periodic table, is a nonmetal, as well as chlorine. So this is actually a covalent compound, and it is not going to split apart, so we're only going to have 1 over here. Okay, so this last one, I wanted to kind of talk about over here. Iron is obviously our metal, and we're going to add it to CO3, and we have 3 of those. So this is a metal. These are our nonmetals, but these are actually covalently bonded. So what that means is this particle right here is not going to break up. Okay, so these guys are stuck to each other. They're stuck together. So when this thing dissolves into a solution, what we're going to see is iron, and we're going to see 1, 2, 3 CO3s. Okay, so we have 4 particles total. So I'm going to put 4 here. All right, the last step is to times it by our concentration. So times by 0.2, times by 0.2, times by 0.1, and times by 0.4. Okay, so I don't know if you guys noticed, but I made a mistake probably because I can't see this here. But this is good because then you guys can see this. This 2 iron means that there's actually 2 of these guys. So if I have 2 irons, I just need to add another one over here, which actually changes this number to a 5, which gives us our answer. Otherwise, C and D would be the same. So let's just go ahead and fix this here. We got 0.5 and 0.4. So your answer is C. So hopefully this is helpful, and if you're still confused on colligative properties, please come talk to me. I would love to help you guys out. I'm on conference call, or you guys can set up an appointment with me. So good luck.